Hello everyone, here is a question from electrochemistry. What would be the mass of copper deposited in grams by passing 9.6487 ampere current through a voltmeter containing copper sulphate solution for 100 seconds? Copper sulphate is undergoing electrolysis here, which means in the aqueous medium we will be having copper 2 plus. The reaction happening at the cathode, half reaction happening at the cathode is copper 2 plus gains 2 electrons and we will be getting copper solid. So, this will be the half reaction happening at the cathode. So, if we have 1 mole of copper 2 plus in the aqueous medium, we require 2 moles of electrons so that we can get 1 mole of copper solid. That is the stoichiometry here. Now, we need to calculate the mass of copper deposited in grams. As per the Faraday's first law of electrolysis, the mass of the substance deposited or liberated at any electrode is directly proportional to the quantity of electricity or charge Q passed. We know that Q is equal to current times time. Therefore, mass is proportional to current times time. To get rid of the proportionality factor, we introduce a constant here called Z, that is the electrochemical equivalence, which is equal to equivalent mass divided by Faraday. Equivalent mass is equal to molar mass divided by valency factor. Valency factor here is identified as 2. Therefore, mass we can easily calculate. Mass is equal to molar mass times current times time divided by 2 times Faraday. That is the equation we are going to use. Therefore, mass is equal to 63 gram per mole times current is 9.6487 ampere, time is 100 seconds, ampere second is coulomb divided by 2 times 96487 coulomb per mole. This will cancel. This one we can write it as 96487 times 10 to the power minus 4. If we do that, then we can cancel this one also. This will be 10 to the power minus 2. Therefore, 0.63 grams divided by 2. Therefore, this will be 0.315 grams. That is the correct answer. Therefore, option 2 is correct.